Before we talk about how do waves interact with matter, I wanted to go back to our previous slide here when we were talking about how that light gets weaker the further away you get. And then we said that also sound gets weaker the further away you get. And then earthquakes get weaker the further away you get. Can you think of anything else that we have talked about in Unit 1 that got weaker the further away you got? And so that was the force of electricity. So if you remember, you had charge number 1 and then charge number 2, and then they were separated by a distance r. And then you had Coulomb's law that said that the further away the charges get from each other, the weaker that the electric force got. Was there anything else that we talked about that got weaker the further away you got? Magnetism. So the same thing is if you had a magnet and then you had another magnet over here, it would obey the same law. And then anything else? Gravity. So in the case of gravity, you got mass number 1 and then mass number 2, as separated by a distance r, and the further away you got, the weaker gravity would get. So there's a lot of things in physics that have this 1 over r squared law. And as we go, we're going to find out some other things that also obey this 1 over r squared thing. All right, but now let's get back to this and talk about how does a wave interact with matter. And I've got this broken up into 2 columns. So column number 1 over here is going to, what does light do? And then in column number 2 over here, what do mechanical waves do? And as far as I'm concerned, for the exam, as long as you understand what is the light waves doing, that's good. But I wanted to show you it works both with light waves and mechanical waves. So the first one is going to be called absorption. And so that first picture in the upper left-hand corner shows what does light look like as it travels underwater. And so the deeper you go underwater, the darker it gets. And that's because the sunlight is being absorbed by the atoms and molecules of the water. So a light wave can be absorbed by matter. It can also happen with sound waves. So for example, this room that I'm in has sound baffling on the walls, and the idea is that outside noises in the hallway theoretically should not be able to get into this room because they will be absorbed by the walls. Okay, so that picture there shows a person putting up sound baffling on walls, and that helps to absorb sound waves. So it's kind of hard to give a definition of what absorption is without using the word absorb. So you could say that the wave is being taken in by the atoms. So the energy that used to be in the light wave is now going into the atoms and is being taken in by it. In the case of sound wave, the energy that was in the sound wave is being taken in by the walls. Okay, then the next one is going to be called reflection. Now, reflection is going to be when a wave bounces off of something. So in the first column, it shows a mountain, and then you can see the reflection of the mountain in the lake. So that what happens is that a light wave can bounce off of something, like a mirror. So that's going to be an example of reflection. You can also have reflection with sound waves. And so there's a picture of a bat emitting sound waves, and then it bounces off the bug and then comes back to the bat so that they can locate where the bug is located at. Okay, then you also have refraction. So refraction is going to be the bending of a wave when it goes through something. So in that case there, that's a picture of a glass of water, and then it shows a pencil put into the water, and you should notice it looks like it's bent. So it looks like the pencil's going in like this, and then it looks like it's broken. So it's bending at an odd angle. And so that is a result of refraction. It's the bending of a light wave when it's going through the water. The picture that's next to it shows an earthquake wave bending as it goes through the earth. So that would be the refraction of an earthquake wave. And then we use that to measure the different layers that are inside the earth. Okay, then you have diffraction. So diffraction is going to be the bending of a wave when it goes around something. And so that picture there is of a razor blade. And if you really need to take that picture and blow it up so that you can see it better. You can find another picture like that very easily on the internet. Just type in razor blade diffraction. And what you'll notice is that around the edges of the razor blade are little distortions, little fringes. And if you look in the center of the razor blade, you'll notice the same thing. So as light is going around the edges of the razor blade, it is being diffracted. It's being bent in different directions. And then in the picture that is over to the right of it, that shows the bending of ocean waves as they approach the shoreline. And notice that the waves, as they are approaching, are bending and making circles like this. What did it do to the shoreline? Do you notice that the shoreline is also curved to match the curved waves that are approaching it? So that would be an example of diffraction of ocean waves, a mechanical wave. So for purposes of the exam, know the definition of absorption, know the definition of reflection, know the definition of refraction, and know the definition of diffraction. And then in a later lesson, we're going to go in more detail and we'll make it more mathematical. All right, let's take a break. And when we come back, we're going to talk about the Doppler effect.